Fog can be a dangerous thing, especially when you're talking about driving in it. But you know, in order to get a better understanding of cars and fog, let's put ourselves inside the situation. Essentially, fog is just a cloud on the surface of the Earth, and clouds are made up of water particles. So essentially what fog is just water. And when you're using the lights in your car, see the floating water suspended in the atmosphere, it acts like tiny mirrors that reflects the light from your headlights back at you, and it scatters it to other drivers. That's what happens when you use your high beams. Visibility can be bad. It's about the worst thing you can do. All you're doing, scattering that light with those suspended water particles. But low beams, they aim the light down at the ground, allowing you to see the road and limit the amount of light bouncing around. So when you're talking about fog this week, do not crank the headlights. Instead, turn on the low beams. Storm surge can be a hard thing for us to understand. I mean, we don't get storm surge here in Michigan, and a lot of people think of it as a big tidal wave. It is not. Think of it like this instead. You see this big pond of water behind me? Storm surge would be like lifting this whole pond up and pushing it that way. You see, storm surge is the biggest threat when it comes to tropical systems. In fact, over the last few decades, almost 50% of the deaths associated with tropical cyclones have come from storm surge. It is the massive energy that a hurricane is. It is churning and swirling and shoving all of that water in the ocean towards the coastline. It can be anywhere from 3 feet up to 6 feet, up to 12 feet. All right, let's try to visualize this in real life. How much water is that? Well, as the storm surge continues to push inland and the water starts rising, going up and up and up. I'm standing here on a 10-foot ladder. Some parts of North Carolina are expecting up to 12 feet of water. 12 feet of storm surge. That's way up here. There are some stronger cells out there, some thunder, some lightning, potentially even some hail with this cell down to the south. Now, as we flatten the map out, show you what's going on in downtown Detroit. And for a lot of us, it is light to moderate rain, but these heavier rain showers are embedded in, and we're going to see those until about 11 p.m. tonight. So this one right here, likely traveling in this direction at this time. By about 6:47, could be around Adrian, 6:53, closer to Tecumseh. That's not the end of it, because as we zoom it out, actually this part of the system has a little bit more of my attention. The middle part of that line of storms has sparked a tornado warning in central Indiana. Now, I'm not saying that that part is going to make its way here, but it is, at least the northern part is strong, and I think that part will. It could clip us, and that would happen right around 10, 11 p.m. tonight. So we'll be watching that all night long. There have been some amazing videos from the Kilauea volcano in Hawaii, but perhaps the most amazing one was posted yesterday by the U.S. Geological Survey. Now, in this video, you can clearly see the blue flames shooting from the ground. This is both rare and dangerous. Now, here's what's happening to make that. The blue flames indicate the presence of methane gas. The methane gas is produced by vegetation, like plants and trees, as they are burned by the lava. See, the vegetation breaks down the gas, and it builds up in underground voids. In fact, the blue flames may have started because the lava continues to approach developed areas, and underneath paved roads is, you guessed it, vegetation. So the concrete is acting as a lid to the gas, allowing it to build up in high concentrations. In a way, it's like the Bunsen burner that you used in high school. When the gas escapes through a crack, it is exposed to heat and oxygen, and it ignites blue flames. The methane explosions could be strong enough to propel boulder-sized rocks high into the air. Before we can determine if something was a spring-like day, we need to define what spring-like is. Let's say this: anything under 45 degrees will be considered a winter day. Anything over 65 degrees will be considered a summer day. Now, if it snowed on that day, we're going to count that as a winter day. Otherwise, this is our definition. So what happened this year? Well, we have had 30 winter-like days from March 1st until today. 23 spring-like days, and get this, only 2 summer-like days. That is 2 days of over 65 degrees. That's crazy. That's nothing. And that's the number that stands out, because when I take a look at the last, say, 10 years or so, and for specifics, let's just use last year. Last year, we had 19 winter days, we had 28 average spring days, and we had 14 summer days. So that's the relief. That's the relief we haven't gotten this year, and that's part of the reason that it has felt very winter-like. Fall in Michigan is when we start dealing with cooler, windier days. But what causes the wind in the first place? Many times it comes down to low pressure, which can mean wet and breezy. So let's make sure we're prepared before we get in here. Globally, wind travels from high pressure to low pressure. The atmosphere is always trying to stabilize, but the strongest winds wrap themselves around a low pressure system. And the strength is determined by these little black lines here. Those are called isobars. They indicate areas of pressure. So the tighter those circles, the stronger the low and the higher the winds. And when that low travels over you, well, you better plan on some gusty winds. So starting tonight, that low will travel over Michigan, which means we'll see an increased breeze tomorrow. Slightly cooler temperatures and above average snow. So what did we get? Now February is wrapping up. You know what? We got them both right. We did have a colder stretch here for December and January, although February was a little bit warmer. On average, it has been a colder than normal winter, and we've seen more snow than we generally see. All right, we all know the melting and the freezing of the water is what creates this nasty pothole mess, but what's the real science behind it? Well, let's start with this. Most liquid, when it freezes, it shrinks. But not water. Water is one of the few ones that as it freezes, it expands. And it has to do with the hydrogen bonds within the H2O molecules. As it freezes, the hydrogen bonds will push apart the rest of the molecules, and they will allow it to expand by as much as 9%. You're looking at rain, you're looking at sleet, you're looking at snow. But what's happening with the atmosphere to bring us all different types of precipitation in one? And for that, let's take a look at the atmosphere in a three-dimensional mode, the different types of precipitation and what causes them here. And all of it has to do with either warm air or cold air and how high up in the atmosphere it goes. We haven't gotten any of those in February, and it has people asking, why? What has happened with the atmosphere to bring winter? And I think one of the best ways to describe it is to have a dinner party. So that's what we're doing here right now. We're going to have a dinner party, and we're going to invite some guests over, and those guests are going to be three different things. We've got cold air, we've got the jet stream, and we've got Gulf moisture. But like any dinner party, the timing of when these guests get to your house is important. Guest number one got here first. The jet stream moved way down to the south. After guest number one arrived and parked his car, guest number two showed up. That's that cold polar air that shoved all the way down from northern Canada. That has settled in, and that's not going anywhere anytime soon. And guest number three arrived almost at the exact same time. And because of the timing of all of these guests, we've got the snow moving up. So the moisture comes up from the Gulf of Mexico. It hits the cold air that the jet stream allowed in, and it brought all of it together, and it brought winter here. Now here's the deal with this. Like any house party you throw, any dinner party, sometimes the guests don't know when to leave. That's the case right now. All right, check this out. A picture I took a couple of days ago. My car says it's 106 outside. It wasn't, but this happens all the time. And it's okay, be honest. It makes you think
that weatherman is wrong.
But I'm here to tell you there's more to the story. I went to Kenny the car guy for an education on why this happens.
Your car relies on one small sensor in the car to tell you what the ambient temperature is outside.
A thermometer?
A thermistor. It's a sensor that measures ohms and resistance.
So not a thermometer?
Not a thermometer. It's kind of hard to see, but right here where this blue connector is where the thermistor is.
All right, here's the science behind it. Thermometers like this one actually measure the ambient air temperature, but that's not how thermistors work. Units like this one measure voltage. The back end of the system is the snow. That moves in between 6 and 7 a.m. tomorrow morning. It's not a lot of snow, only about 1/4 of an inch to 1/2 an inch. After we see that through the morning, we will then start to dry out. Let's pull things back to what's happening tonight. Between 5 p.m. and 11 p.m., we are watching the threat of hail and some flooding with that heavy rain. Ground is already saturated due to the melting snow, wind and lightning. All those things are going to be our concern, and wind and lightning a little higher so. A lot of people have been complaining that this March has been unbearable. It's been too cold. It's been too snowy. Well, you know what this video is? This is of the Northeast. This is the 4th major snowstorm they have had since March 1st. Hundreds of thousands of power outages, thousands of canceled flights, and a ton of snow. How much snow? Check this out. Portland, Maine, 31.6 inches of snow since March 1st. Not for the year, since March 1st. The 4 big systems for Worcester, Massachusetts, 40 inches of snow since March 1st. You know how much we've had since March 1st? 5.9 inches. So yes, I know, it's been kind of a nasty March. We're all ready for the warmer temperatures. But before we go complaining too hard about our 5.9 inches of snow, maybe we should remember that it could be outside looking like that.